Hello everyone, welcome to the video. Now in the previous video we talked about these different power quality issues in the part 1. Now this is the part 2 of the video wherein we are going to talk about the voltage imbalance, the waveform distortions, voltage fluctuations and power frequency variations. The video is definitely going to be an interesting one, so make sure you watch it till the end. So let us start with the voltage imbalance. So voltage imbalance is when the voltage phases or phase angle in a multi-phase systems are not equal. Very simple and clear definition. What I want you to understand is when we say 440 volt AC, that means it is an average value of a three-phase voltage system. You can see the waveform here. Now this value is only true when all the waveforms are identical and the phase angle between the different waveforms are similar, then only this value is true. In case if any of the waveforms are not equal or the phase angle is not the same, then this value is not going to be true, and that is what we call as the voltage imbalance, and it is mostly seen in the multi-phase system or the polyphase system. You can see the one example here. We have two phases which are like perfectly in sync with each other, but the phase one is not in sync with the other two, and as a result there will be a voltage imbalance. The most obvious reason of the voltage imbalance is the single phase load that we put on the three-phase system. So mostly all the distribution systems will be having this issue of voltage imbalance because when we distribute the power, we don't always have the three-phase load. We mostly fed the single phase load like the residential zones or maybe the small commercial areas, and that will cause 100% imbalance in the system. Also, if there are some incorrect tap setting done for the transformer, that can also result in the voltage imbalance. Now having a balanced load is very crucial. Now I've already talked about what is balanced load, what is imbalanced load in one of my videos. I'll put link for that down in the description. You can go and check it out after this video. So those are some of the common causes of the voltage imbalance, which takes us to the next point, that is the waveform distortion. Now as the name suggests, it is the problem of the power quality in which the waveform is completely disturbed. Now the ideal waveform is the sine waveform, which you can see on the left hand side of the screen, and on the right hand side of the screen you can see a waveform which is completely distorted. Now that is nothing but the waveform distortion. When an ideal waveform disturbs from its shape, then it is called as the waveform distortion. Now waveform distortion can have multiple types in that. So first we have the DC offset, then there is harmonics, then there is interharmonics. Notching and noise are the different categories of the waveform distortion. Let us quickly talk about these one by one. First, let us start with the DC offset. Now what is DC offset? DC offset is simply the presence of DC voltage in the AC system. Now certainly we are not inserting DC voltage in the AC system. What is happening is, now if you see the AC waveform, this is the AC waveform, right? Now if in this waveform, if the voltage doesn't go to zero and just it stays on the positive side or it stays on the negative side, then it becomes the DC voltage, right? Or if you can see my positive peak is more than my negative peak, then that means it's an asymmetrical waveform, and that is nothing but the DC offset. You can see one example here. Now this part where the waveform is completely asymmetrical, the positive peaks are more and the negative peaks are less. As a result, this is an offset, and this is called as a DC offset. And after a certain period of time, you can see the waveform becomes normal where positive and negative peaks are equal. That is called as symmetrical peak, and the balance is called as asymmetrical peak. And this is nothing but the DC offset, because the waveform is not going to zero position at the right time. It is causing a DC offset. Now majorly this DC offset is caused by the power converters, majorly the non-linear loads. Power failure can also result in the DC offset. Even some short circuits can also result in the DC offset, and that is the reason why you will find circuit breakers, they will have the asymmetrical breaking current capacities as well, because there is a DC offset and circuit breaker needs to interrupt that current as well. So that is the reason you will see on the nameplate or in the details of circuit breaker asymmetrical breaking capacity is also mentioned. Clear? So that is DC offset, which takes us to the next point in waveform distortion, that is the harmonics. Now harmonics are the sinusoidal voltage or current having frequencies that are integer multiples of the frequency at which the supply system is designed to operate, which is nothing but the power frequency. And power frequency, there are two power frequencies that we have. One is 50 hertz and another one is 60 hertz. So when we say harmonics, it means that it is integer, it is the voltage or current signal which is integer multiple of the power frequency. So it could be, let's say, a current waveform which is going at the 2 into 50 hertz frequency, which is 100 hertz. This is called as second harmonics, or if it is the fourth harmonics, then it means 4 into 50 hertz, that is 200 hertz. So it is a voltage or current signal that is going at 200 hertz. So in normal scenario, the signals will go like this for 50 hertz 50 times in a second. But if it is a fourth harmonic, or let's say the second harmonics, then the voltage and current signal will go at 100 hertz frequency, 100 times per second. So that is the harmonics, and you can see the example here. Because of the presence of different harmonics in the system, the waveform is completely distorted here. Now, this is a very critical problem in the power system, and there are dedicated harmonic filters, and the devices to take care of the harmonics are fitted in the low voltage switchgear as well. And there are multiple reasons why these harmonics are produced. So first is the power converters that we use, because they take the current abruptly, so there is no systematic way they consume the current. They can switch the current at any time, and as a result they will introduce the harmonics in the system. Different non-linear loads will cause the harmonics. Variable frequency drives is again one of the important source of harmonics, because to control the speed of motor, we are changing the frequency, we are playing with the frequency, and that will introduce harmonics in the system. Even the computers that we use, the different chargers that we use, that will have a lot of thyristors, diodes, mostly the non-linear loads, and they will introduce the harmonics in the system. Transformer also to some extent introduce the harmonics, and arc furnaces are also the classic example of the harmonics, because they will consume the current abruptly. So there is no systematic way how they consume the current. So it's an abrupt consumption of the current, and as a result the harmonics are introduced in the system. Now for sure we can definitely have a dedicated video talking about the harmonics. Now if you want me to make the video on the harmonics, then do comment harmonics in the comment section below. If I get enough comments, then definitely I'll be making video on harmonics dedicatedly. Now to avoid this harmonics, there are dedicated panels introduced in the low voltage switchgear to control the harmonics. So that is power quality panels basically. And by the way, if you are interested in learning about the low voltage switchgear, if you are someone who is just entered into the industry and you're looking for a basic understanding of low voltage switchgear, then you can definitely check out the low voltage switchgear level 1 course that we have. The course is taught by the industry expert. It gives you 10 to 12 hours of self-paced content. You can learn at your own speed and learn directly from the industry expert. So definitely it's very unique and useful course where you get all the required information in one single place. I'll provide a link for this also down in the description. You can go and check it out after this video. Which takes us to the next point that we have is interharmonics. Now interharmonics are also the harmonics, but they are not the integer multiple of the power frequency. That is the only difference. The causes of this are more or less similar to that of the harmonics that we talked about. The difference is harmonics are the integer multiple of the frequency. Interharmonics are not the integer multiple of the power frequency. That's the difference between these two. Which takes us to the next waveform distortion topic, which is notching. So notching is a periodic voltage disturbance caused by the normal operation of power electronic devices when current is commutated from one phase to another. You can see one example of the notching here. So when we say notching, it is mostly related to the voltage. Okay, it's a voltage disturbance in the system, and it's periodic in nature. You can see we have here notching, here, 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 here. So all the waveform, basically there is a periodic disturbance that is happening in the voltage, and that is what we call as the notching. One of the most common reason for notching in the system are the different three-phase converters that we use. So if you have HVDC system which will convert this power from DC to AC or AC to DC, this problem can be noticed there, voltage notching. Then the next waveform distortion that we have is noise. Now electrical noise occurs when a random electrical signal gets into the circuit and disturbs the information carrying signal. Now this can have impact on both power signals and also on the communication signals. Mostly the impact of this is seen on the different communication signals that we pass through the electrical lines. And this is basically, it is seen that when the signals are less than 200 kilohertz, it is categorized as the noise in the system. Now noise in the power system can be caused by power electronic devices, control circuits, arcing equipment, loads with solid state rectifiers, and switching power supplies. So basically all the electronic devices are the reason of the noise. Now it really doesn't mean that all the electronic devices are bad. No, those are required because that those makes our life easy. But for sure it will cause some impact in the power quality, and that we have to mitigate. Which takes us to the next problem of the power quality, that is voltage fluctuation. Now this is one of the common and the critical problem. Voltage fluctuations are a systematic variation of the voltage envelope or a series of random voltage changes, the magnitude of which does not normally exceeds the voltage range specified of 0.9 to 1.1 per unit. So it is basically the voltage changes that we see on a regular basis, and the range of which is not generally goes below 90% and above 110%. Now this range can vary based on the different standard. The range what you can see on your screen is defined by the American National Standards, ANSI. And you can see the example of voltage fluctuation shown on the left hand side. So you see there is random changes that is occurring in the voltage. Now there are several reasons why voltage fluctuation can occur, and it is also very commonly seen. So changes in the load, changes in the generation, changes in the network configuration, pulses, power output, resistance welder, arc furnaces, rolling mills are some of the causes of the voltage fluctuation. Now you would have also noticed this fluctuation in the home when the lights flicker, right? That flickering is basically caused by the voltage fluctuation, and that is also the reason why a voltage fluctuation can also be called as flickering. Voltage flickering and voltage fluctuations are the words that can be changed with each other, right? So which takes us to the next and the last power quality problem, that is the power frequency variation. Now as the name suggests, power frequency variation are defined as the deviation of power system fundamental frequency from its specified nominal value, which could be 50 Hz or 60 Hz. So when I say my frequency is 50 Hz, and if this frequency is getting deviated, it is basically a problem of power frequency variation. Now you can see one example on the left hand side. If the standard frequency is 60 Hz, but there is a variation seen throughout the day, and that variation is about 59.95 up to 60.05. The variation is not very big, it's very minimal, but it can be a problem, it can be a power quality issue. Now in the modern power system, this issue is not very frequent, it's a rare occurrence. But it is always good to have the information about such scenarios as well. So those are the different power quality problems that we see. So this was the part 2 of the video, in which we talked about the voltage imbalances, we talked about the different waveform distortions, we saw DC offset, we saw harmonics, we saw interharmonics, notching and noise. Then we also talked about the voltage fluctuation, and lastly we discussed about the power frequency variation. I hope you got the idea about all these different power quality issues or power quality problem. If you found this video helpful, then do like the video and do share it with the people you think might be interested in knowing. That is all for this video, guys. I'll see you in my next one, but till then, Keep watching, keep learning.